Hello, Algebra 1. This is Lesson 91, Multiplicative Property of Inequality, as well as Spheres. We're going to start off with that multiplication property. We have worked with inequalities before. The new topic here today is when we multiply or divide by a negative, we end up flipping the sign of the inequality. So you can see in this example up here, where it had originally been a greater than symbol, it gets flipped to a less than symbol because of multiplying or dividing by a negative. And again, another example here that we can focus in on. As soon as we divided by a negative, that flips the sign of the inequality. Okay, so we're going to just try some practice problems to make sure you're understanding that concept. This is star 1 from the notes that were sent to you by email. So we start off with negative x is greater than negative 1. And this is almost solved, except for the negative out front. So I would need to multiply both sides by a negative 1 in order to get x by itself. So I now have x by itself, and the right side of the equation is negative 1 times negative 1, which would become a positive 1. And then the big deal here is that we flip the sign in the middle. It is now a less than symbol. Okay, we're going to go ahead and create a graph for this as well. So it's not just this inequality solution, but we also are going to graph it. We can make a pretty simple number line. I want to focus on the number 1 being in the middle. And then I'm going to go just a couple each direction, moving up and down from that 1. Okay, and I'm going to focus in on the inequality symbol is a less than symbol, which means that we are going to be going left. We also have it as an open circle because it does not have an equal bar. So we have an open circle, it's going left, and we just show that continuation with an arrow. Moving on to question 2. This one is a little bit more complicated. We have an additional step when we're solving the algebraic part. So the first thing I'm going to do is solve algebraically. I will need to subtract the 1 to the other side in order for it to cancel. I'm left with negative 2x is less than or equal to 6. And then the next thing I'm going to do is get x by itself by dividing each side with negative 2. And right there is the alarm going off because we are dividing by a negative. The left side is just x, the right side is negative 3, and this is where that flip takes place of the inequality symbol. So we are left with x is greater than or equal to negative 3. To graph this one, let me just start that over, use my blue. To graph my number line, I focus in on negative 3 being kind of the focal point, and then I go smaller or bigger from there. And it is going to be a closed circle at negative 3 because of that equal bar. And it's also going to go to the right this time because it's greater than. So there's my completed graph for star 2. Okay, there's a second topic in this lesson, and it is about spheres. A sphere is a three-dimensional circular shape, much like a marble. You're going to have two formulas today. One is the volume, which is the capacity if you were to fill up this marble with something. And the other is the surface area, which is the area all the way on the outside around the sphere. Okay, so we're going to start off here with star 3. Find the volume and surface area of the sphere that has a radius of 6 meters. So I'll start with volume. Let me just copy down my volume formula from up above. It is 4/3 pi r cubed. There's only one thing that gets plugged in on this formula, and that is the radius at 6. So when I go through and solve that, 6 cubed is 216. Multiply that by 4 and divide by 3. Okay, so my one step here I'll show in between. 6 cubed, 216. And you're welcome to grab a calculator, multiply 216 by 4, divide it by 3. You should get a fraction. We're not wanting the decimal, or actually this one comes out as a whole number. 288. And then we keep our pi. And we are working with meters, so this is going to be cubic meters because it is volume. Okay, that one is your volume formula. Now we're going to do the same sphere, but we're going to work on the surface area. So you'll pull your surface area formula from above in green. It's 4 pi r squared. And I'll write that over here. Once again, we only have one thing to plug in, and that is our radius. Our radius for the sphere is 6. And 6 squared is 36. So we're going to multiply 4 times 36. Keep this in pi form. So my answer is 144 pi meters squared, because surface area is only a square unit, not a cubic unit. Okay, and so that's my solution for surface area for star 3. We're going to move on over here to our practice questions out of the book. Okay, so the first few questions are going to be working with those inequalities. Question A, if you're following in your book, you guys are on page 381. Negative x is greater than or equal to 5. And there's a note that my domain is all real. So it is the reals number system. Okay, this one doesn't have a lot of math to it. I just need to get rid of that negative out front. So I do that by multiplying both sides by -1. The result of that is x is just x, and the right side becomes -5. But please remember that you have to flip your symbol. Okay, so that's the inequality solution, but we are also going to be graphing it. So on my graph, I'm going to focus -5 in the middle. And I'll go just a couple each direction. Confirming that it is a less than equal symbol, so that means it is going to be a solid closed circle. And it will go to the left for less than. And there's my graph for question A. Going on to question B. Again, this is page 381. The original problem is 2 minus x is not less than or equal to 1. And this time my domain is going to be the set of integers. Okay, so you may recall that's going to change our graph a little bit when we get to that step. The first thing I'm going to do is deal with this less than equal to not symbol. When we have a not placed there, it means we have to do the exact opposite. So we don't just flip it and get greater than equal, we do greater than, so that it's exactly the opposite. So I'll rewrite this as 2 minus x greater than 1. And I need to subtract my 2 to the other side. So I get -x greater than -1. Now we're in that same position as we were before, where we need to multiply both sides by a -1 in order for x to be by itself. So now I have x and I have 1, and I am going to change my symbol, flip it in the middle, so it's x less than 1. Okay, so that's my solution in the inequality form. Now I'm going to go ahead and graph it. I'm going to place 1 in the middle. And I'm going to go each direction by a couple numbers. And then this one is a little tricky because of the integers. Integers would be whole numbers, whether positive or negative in this case. So whole numbers, but not fractions, not decimals. And the fact that it's less than 1 means we cannot bubble in 1. So we're going to go smaller than 1 and put in our first dot, and it would just be dots all the way down. To show that this continues, I fill in my arrow. Okay, so that one is question B. Let's move on to question C. This one is negative 3x plus 5 is greater than 1. My domain is integers again. So when we go to graph it, we'll remember this is the bubble type. All right, so my first step is I'm just going to approach it algebraically. I'm going to subtract a 5, move it to the other side, and I get negative 3x is greater than negative 4. Now when I want to get x by itself, I have to divide both sides by a negative 3. On the left side, I have just x. On the right side, I'm going to have 4/3 when I cancel out those negatives. And then because I divided by a negative, I am flipping that sign. So my solution is x is less than 4/3. When I go to graph that, I may want to take a moment to remember 4/3 is actually 1 1/3. If I want to look at it as a mixed number, it might make it easier to graph. So when I make my number line, I am going to have 1 and 2 because the number falls slightly in between the two. And then I'll just go a couple more each direction. Now I'm going to focus up on my domain. It is integers, so it's going to be only the dots of the numbers that are included. Well, 1 1/3, just for note, is approximately right here. But we're not going to graph on that. First of all, it's not a whole number. It's not an integer. And secondly, we are doing less than without an equal symbol. So what we actually end up graphing are the whole numbers or the integers from positive 1 on down. And then we do our filled in arrow to indicate it's going to keep going. So that's what my graph looks like for question C. Moving on to question D, we're going to do a sphere question. Find the volume of the sphere whose radius is 4. So I'm going to start off by writing my formula. I'll say that again because it's important. I start by writing my formula. Then I plug in the radius that's given. In this case, the radius is 4. And if you don't have memorized 4 cubed, you can grab your calculator. 4 cubed is 64. Then we multiply that by the other 4 in the front, and we're going to get 256 still over 3 pi. And this was in inches. Since it's volume, it's cubic. So there is my solution for question D. Volume of the sphere. I'm going to move on to question E, which is the surface area of a sphere, radius 5 feet. So I start by writing the formula for surface area, and that is 4 pi r squared. Plug in what my radius is equal to. It is 5. And then we know 5 squared is 25. You're going to multiply it by the 4 out front. And so your solution here would be 100 pi. Unit is feet, so it's feet squared because it's surface area. Okay, so that's my solution for question E. The homework for this lesson is actually on Delta Math, and you have not yet been given the code to log into Delta Math because we're still waiting on Google Classroom attachment to that. So you have a little bit of a homework break until we get that code. Good luck and look forward to talking to you guys soon.